Hi. Today we will find out what an electric flux is. What are the major components in it? How do we calculate it? But before we start, hit the subscribe button and notification bell, so that you are the first one to watch our next video. So let's start. Now before moving to electric flux, one of the major components we need to clear of is area. In simple terms, the area is the length of the figure multiplied by the breadth of the figure. But very few know that area is a vector quantity. Meaning we also need to take into account the direction. And moreover, we also need to see that the object whose area needs to be calculated, is closed or open. Let us try to understand this with an example. Let's say we have a 3D plane x, y and z. And a paper of length a and breadth a is kept on the xy plane. So according to theory, area if the paper is equal to a square, magnitude-wise. And in vector terms, area is equal to AB vector cross BC vector. Since the length of AB vector is a, and length of BC vector is also a. And we also know that in the cross product, we take the sine of the angle of the vectors. And the angle between the AB vector and BC vector is 90 degrees. So the area is equal to a square into sine 90. Which is equal to a square k vector or minus k vector, since the paper is in xy plane. So this is how we calculate the area of any open surface. In an open surface, area vector can be in any of the perpendicular direction, coming out of the plane, and going in the plane. Now let us look into an example of a closed surface. Let us take an example of a cube with the length of a on each side. Now according to the formula, area vector for this particular plane, is equal to a square into k vector or minus k vector. K vector is coming out of the cube and minus k vector is going into the cube. So out of the two options, we take into account k vector only. Meaning for all closed surface, only the vector that is coming out of the surface from the inside of the object is taken into the account. Not only for cubes, but this rule is also applied for all closed objects. Cylinders, spheres, box or any closed surface. Only the outward normal is considered as an area vector. This entire calculation and theory are needed to calculate the electric flux line. Area calculation is a major component in calculating the electric flux. Now how do we calculate the electric flux line? Let's discuss that in part 2 of this video. Keep watching the next video to continue exploring. And do not forget to check the exclusive offers, link in the descriptions. Let us meet in the next video.